So the main element of any electrical power system is there is a lot of circuitry, and obviously the circuit, any circuit to work will need a power source. You must have in your school, you must have developed some circuits where you have used basically a battery, but here in this case it will be large power generating stations, and from there the power is, different types of steps are involved. The power is transported through cross country transmission lines. They may be thousands of kilometers long, and then ultimately they are distributed among the consumers. And so we have introduced about the transmission companies, generating companies, distribution companies, and each of them is actually doing some business, is into some of business, and that is how it works. And we also pay for the services that we take for these power utilities. Now, since this is a course on electrical technology, in this course we will be basically discuss. It is just a one semester course, maybe 38 hours, 40 hours. We'll just discuss the basic elements that make up this power system. So that is how the syllabus is made, and it is actually relevant to all branches of engineering. So all branches of engineering should study this. I think at least the basic elements, and then if anybody is interested to go deeper, then there are advanced courses on it. And nowadays, again, another very important aspect that is coming is basically the renewable amount of the renewable sources. So which are actually they are basically a source of clean energy. The renewable sources, whether it is the windmill or the solar power, they are basically a source of clean energy. They don't pollute the environment, and you basically harness some of the natural phenomena. But then there is some disadvantages with it. They are not always available, since it is dependent on the weather. It is all weather dependent, and then but we need power around the clock. So at the grid level, or at the grid management level, it is basically a very critical management, how to provide uninterrupted power to the customers, because we need uninterrupted power to run railways. We need uninterrupted power to run the hospitals. We need uninterrupted power in the class, everywhere. Any big steel plant, they need uninterrupted power. There should not be any power interruption. We feel very uncomfortable if power gets interrupted even in our home. Or suppose you are watching a, say some World Cup soccer or cricket, some finals in the floodlight. So the power has to be uninterrupted. It should not happen that the power goes when, at the crucial time of a match or at any time of the match. So that is the uninterrupted power that is required. That if we play the floodlight even at night, so that is it will look like a daytime. So in this course, we will be studying different types of basic principles that are required to handle electrical energy. So in the previous class, we basically started the discussion on the nodal analysis. That is to solve the electrical circuits uh, uh, using the nodal analysis method. So we'll start with that, and then we will go ahead. So can you see my screen?
Yes, sir.
Yes, sir.
Sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
So this is the thing we discussed yesterday with a
Yes,
very
sir.
simple example, the nodal analysis. That means before that we had discussed about the different type of sources. We discussed about the voltage source, we discussed about the current source, and then we discussed about the independent, dependent sources. We did that entire classification of the types of sources that are possible. And we also told about the things that we will discuss. We will basically not discuss any dependent source. Okay, so but we showed the entire classification, how the sources are classified. The purpose of showing the classification is some of you may be studying those dependent sources also, but in some other advanced course, not in this course. So in this course, we will restrict ourselves to independent sources only. So we discussed about this nodal analysis. That is so nodal analysis is basically an analysis using the KCL or Kirchhoff's current law, and we described with this example. That means, suppose this is the problem that is given. So what we do is we identify the nodes that can be that are common, and then we combine them to make it a reference node. And so once one node is reference, so the total number of nodes reduces. So an n node circuits get reduced to n minus 1 nodes, because one being the reference node. And then we give the the existing nodes, assign some voltage values, and then we write down the by deciding the directions, we write down the KCL equations correctly. Obviously, correctness is required in the KCL equation. If you write your equation wrong, then your whole entire final answer will be wrong. So you have to follow the step-by-step procedure, give the directions, and then prominently, and then follow those directions and write down the equations correctly. Okay, so that is how the KCL the KCL is has to be written, and then you write down the KCL at all the nodes, and then ultimately we solve the equation to get the voltages, the terminal voltages. So and we also showed this technique that we may, because we may have large number of nodes, so you have to solve the problem with a large number of variables, and we basically you can make use of Cramer's rule.
Sir, can you show the problem statement once again?
This one. This was
Yes,
done
sir.
yesterday. Yeah.
Yes, sir. I told you yesterday that my net connectivity was very weak during the last half an hour of the class. I wrote it in the chat, so I could not see it.
Yeah, so you should take down the video then, So all of you should not, mute, should not unmute yourself unnecessarily. If there is some background noise, you mute yourself. Otherwise, I will force to mute all, which will actually hamper this interaction. So if there is some background noise, you should make sure it is muted so that it does not affect the entire class. Anyway, so have you seen this?
Yes, sir. Yes, sir. Thank you.
Yeah, so I can also forcefully mute you, but then the interaction will be stopped. So ultimately, so these equations, okay, two variable problem, you have been learning how to solve it from your school days. But if you have a multiple variables, then it cannot be solved, and basically by hand it will take time, and even during exam it is not possible. So it is better done by some automated method, and by using the the theory. So by solving this, we got this V1 equal to 5, V2 equal to 2 volts. So this was the problem we did yesterday, and then I gave this problem to solve. Any one of you have done this? I
Yes, sir. Yes, sir.
So who has done?
Yes, sir.
What is the answer?
Sir, if we take reference point all the downward nodes, then V1 will come 720 by 19 into 7 volt. V2 will come 147 by 19 volt, and V3 will come 880 by 19 volt.
V1 is how much? Give me in decimal.
1 second.
So that was minus 8 amperes.
Slightly big.
88.41 volts, sir.
No.
V1.
It is not that.
Sir, 14 volts. Sir, V1 will come 5.4 volts. V2 will come 7.7 volts, and V3 comes
Yes, sir.
46.
V1 will come 5.41.
Yeah,
Sir,
so you have to
V1
be
is
very, very. I am getting all sorts of answers, but some answers I am hearing are correct, but many of them are actually wrong. So
Sir, V1
all. So what is actually, it is not a very difficult sum, but what will actually, it will boil down to writing the equations correctly. If you write wrong equations, if you don't follow the sum conventions properly, then you'll basically end up using wrong equation and ultimately getting wrong answer. Okay, so suppose we choose this direction. Suppose this direction from the node 1 to node 2 is in this direction, then node 2 to the reference point is in this direction. So we fix the directions. Node 3 to through this in some direction. Again, there is a branch here, 1 to 3, node 1 to node 3 in this direction. So if you apply the KCL at the node 1, okay, if you apply KCL at node 1, the current going is what exactly we follow this, what is written here, current, even if it is negative or what, it is showing in this direction and the minus 8 ampere. So let us follow this, current going in is positive. Okay, so it is basically minus 8, whatever is written comes here. So current going is, we consider positive. Okay, so similarly here the same another current comes in which is minus 3. Okay, and the current going out is basically negative. So current going out here will be what? So this is the this 3 ohm is between the two nodes 1 and 2, which is having a voltage V1 and V2. So this is what? The current going, this current is how much? V1 minus V2 by 3. Okay, but current going out is negative. So we will take minus V1 minus V2 by 3. Okay, similarly the current here through from 1 and 3, we have assumed this way, and the current is basically V1 minus V3 by 4, and since it is away from this node, so again it is minus
Excuse me,
V1
sir.
minus
Sorry to interrupt, but I think the current in the leftmost branch was -8.
current, yeah, minus
Current
8,
in the
yeah.
leftmost branch.
I made a mistake. Okay, this will be that is a typing mistake. Which one you are telling? Leftmost branch means this one.
The leftmost, the branch
Uh-huh.
which is 8 ampere is written, that should be -8 amperes.
No, I have written minus 8 only.
I'm not able to see the negative side.
So that may be some other issue, but it is written minus 8. Others can see?
Yes, sir. It's
Yes,
minus
sir.
8.
Yeah,
Yes,
minus
sir,
8.
it's minus 8.
Yes, sir.
Yes,
So
sir,
it
it's
is,
visible.
so the current going to the node 1 is
Only 8.
positive, so it is minus 8, just exactly as it is given. Similarly, this is minus 3, and then this going out is taken as negative, so V1 minus V2 by 3, negative, and then V1 minus V4 by V1 minus V3 by 4 equal to 0. I made a mistake here in typing. Okay, so that is how once you apply KCL to node 1, you get this. Then similar thing you have to do by writing the KCL for node 2. Okay, so for node 2, the current going in, what is the current going in? V1 minus V2 by 3. This is the current that is coming in to the node 2.
Yes, sir.
V1 minus V2 by 3. Then minus of minus 3, because this is the current going out. Current going out is negative, so minus of minus 3. Okay, and then V1 minus V3, V1 minus V3 by 7. Sorry, this will be again V2 minus V3 by 7. Sorry, this is again V2 minus V3 by 7. Yeah, typing issues are there. Can you see?
Yes, sir.
V2 minus V3 by 7.
Yes, sir.
Okay. V2 minus V3 is assumed in this direction. Okay, the current that is going in this direction. Obviously, this one arrow should have been given here, one red arrow directing from 2 to 3, going out. And similarly, there is another current which is
Minus V2 by 1.
minus V2 by 1. Okay, so that is
Yes, sir.
another equation. Similarly, applying the KCL at node 3. So at node 3, the current is from 2 to 3. Sorry, again, let me put this, that is,
Excuse me, sir.
yeah.
So for the current in 1 ohm resistance, have you assumed the load potential to be 0?
Yes.
Yes.
Okay, sir.
Yeah, this arrow was not there. So arrow from 2 to 3. So now it is there. So it is, so at node 3, the current going in is V2 minus V3 by 7. And then the currents are going out. This is the current going out. So it is minus of minus 25. Then the next current again going out. Not going out, it is the current coming in from here. See, originally the direction was kept here, so it is V1 minus V3 by 4. So that is the current coming into node 3. Because these 2 points are same. Okay, so this is all of node 3. And then what is remaining? Another
So
current
5
going out.
5
V3
ohm.
by, V3 by 5. Not 5
Yes.
ohm, V3 by 5. This is the
Minus
current that
V3
is,
by 5.
yeah. So once you solve this, so you have to basically now solve this. You have to write down these equations in terms of keeping V1, V2, V3, the unknowns on the left hand side with the coefficients, and whatever constants are there goes to the right hand side. And then you can apply, there are 3 variables, you can apply Cramer's rule and solve it. Okay, and so once you solve it, what do you get?
Sir, V1 equal to
V1 is
4.09.
5.
No, so many answers.
5.41, sir. 5.41.
4.09 is wrong.
Sir,
Okay.
5.41.
5.4.
5.4.
5.41. Okay.
4.1.
Yes, sir.
Yes.
V2.
So 7.73, sir.
7.7.
So writing the correct equation first, once you are given a problem, giving the directions and just following the directions. Okay, once we have put down the directions, you see I have specifically marked the directions in red. Once I have given the directions, you will have to actually stick to those directions, but you can put the directions other way also, but then you have to, from the beginning only you have to do that. You cannot change the directions once you have chosen it. Okay, so otherwise it will become a different equation. So writing the correct equations, writing the correct KCL equations is very much necessary. Any mistake in plus minus sign will actually lead to wrong coefficients and ultimately wrong solution. So V2 is 7.736. Anybody got this?
Yes, sir.
Yes, sir.
Yeah, and V3?
Sir,
46.31.
46.31.
46.
Yes,
46.315.
Yeah, so that is how you have to do it. So that writing the correct equation is essential. So understanding the concepts of the theory or the law, and then how to apply it for any given problem is very much essential. Otherwise, you will end up writing wrong equations and ultimately the wrong answer. So if you end up writing wrong equations, you will not even get the partial credit. Okay, so that is how the so this is the nodal analysis. Okay, so I think all of you have understood this.
Yes, sir.
Sir.
Can we consider the potential
Yes,
node 1 0
Yes,
and
sir.
solve the
Yeah,
potential of
repeat again.
so can we consider the potential of node 1 to be 0 and calculate the potential of nodes 2 and 3?
No, whatever you assume, you have to strictly follow. You can try it whether, but it will again give a different answer. So if you make that as the reference, it will basically lead to another different circuit. Okay.
So
Sir, in
Sir,
this
how to
circuit,
use the
Sir?
reference?
what you are
Yeah.
taking as sir, in this circuit, what you are taking as reference?
I have taken the
Point.
reference at the ground level. The lowest the line is there. If you combine them, it becomes actually one node.
point. Okay,
So
sir.
all are at the same potential.
Sir, if there are more nodes, they will mention the reference, right? Otherwise, the values will be different.
Yeah. But once you are given a circuit, you just tend to like this circuit, all the sources are some node which is supposed to be the reference is obvious. Actually.
Yes, Amit. Like it's connected to most elements.
Yes.
Okay.
Sir, can we do using current, sir? Kirchhoff loops la.
Huh?
You have done, sir. Can we do like this? We'll assume that currents like I1, I2, and sum of the potential difference across the loops equal to 0.
You can try whether it will work or not. You have to try. You have to show actually by
But sir,
solving
there will
what
be
you have
much
said.
more variables in that process.
Yeah, so that is also so the advantage of nodal analysis is whatever is the number of nodes, you basically making one node as the reference, you basically come down to n-1 nodes, and so you have to write down the n-1 equations, because there will be n-1 variables, so those you have to write down n-1 equations and solve for those variables. The problems it is better to envisage the problem in a simple way rather than making complicated assumptions and all. Most of the problems are actually simpler.
Sir, is there any way to choose the loop, or means randomly we can choose any loop?
No, I have not come into any loop so far. I have not gone into any loop so far. I have just considered the node voltages and considering the currents in the different branches. I have not.
Sir,
I have not.
how to choose the reference node?
Yes, sir.
Reference node is you consider where most of the elements are connected. Somebody told, and just consider one of the reference, and your answer will be with respect to that reference. If you choose some other reference, then your answers may change.
So sir, this is the relative voltage.
So here it is obvious. This is the ground point because this is the way this problem is given. All the two current sources, they are connected at the same point. So since some of you considered about these loops, so the next thing is we have to see is the method which is known as the mesh analysis. So nodal analysis was with respect to using the KCL. Now mesh analysis is actually, this is the technique that is applicable for planar circuits. What is the meaning of planar circuits? We are basically dealing with circuits. The planar circuits means the circuits that can be kept in a plane. Okay, that means all the circuit elements can have to be lie on a plane. If one circuit element is not possible to be kept in a plane, then that is called a non-planar circuit. Okay, then you cannot apply the mesh analysis method. Now in this course, we will be restricting to the planar circuits only.
Sir, I didn't understand the definition.
I will show because my screen is white. I have not given any diagram. I will just show using the diagram.
Okay.
Suppose we have a circuit like this. Okay, I have shown a circuit. It's composed of several resistances and they are connected, and then there is a voltage source. Okay, so if you make a circuit like this, it is possible to keep them in a plane. It is not that some of the resistances have to be forcibly kept away from the plane because it is touching the other branches. All of them can be very safely kept in a plane and you can make this circuit. So this is basically a planar circuit. But if you have a circuit like this, like the same planar circuit I have taken, and I put some additional branches. Okay, I make two additional branches. Suppose I make one additional branch like this. All of you can see? So I have,
yes, sir.
Yeah, so I have put another additional branch. So this branch can still be kept in that plane. Okay, I put another additional branch, but this branch is still be kept on the plane. Now I put another additional branch. Now if I put this additional branch, you see that blue and that red are basically touching. The point is that they should not be touched. There should not be a node there because we don't want a node there. We just want to connect this node with this by this way. So you see, if you leave it this way, then either you touch this. If you touch this, then then it becomes a node, and we don't want a node here. Then the only way out is to keep this wire away from the plane, above the plane. Okay, so above the plane, if you keep, it will be a circuit, but it is not a non-planar circuit. Or if these 2 points, you just keep it above the plane. Yes.
Sir, what if we insulate the two wires? Then the node will not be formed there.
That is fine, but still it is not in the plane.
Okay,
The wire
sir.
has a certain where is it? I mean,
Conceptually, they are not in the same plane.
Conceptually, they are not in the same plane. Okay, if you can make a circuit, you can have a bulb that will glow and all, but it is conceptually not in the same plane. Okay, because the wire has certain diameter, it has certain thickness. Okay, it is.
Yes,
Okay,
I got it.
yeah. So that is not a planar circuit. So we got a non-planar circuit. And if it is a non-planar circuit, this mesh analysis cannot be done. Okay, so in this course, we are not considered about these non-planar circuit elements. We are only bothered about the planar circuit. So if a circuit contains m meshes, so that means this planar circuit. So you see, if each of these windows are basically a mesh. Okay, so if you move within the window, you are basically encountering one mesh, and so if a circuit contains m meshes, then we can expect to have m mesh currents, and so ultimately we have to write down m independent equations. We will actually come up with an actual example, because the diagram that I'm showing is abstract. I don't know, no values are given. We'll actually have to do a lot of problems also. So if there are, please unmute. Whoever is background noise is there, please unmute. Otherwise, I will forcibly mute, and then there will be no interaction. Okay, so I want more interaction. So if a circuit contains m meshes, then we have to, for finding out those mesh currents, we have to write that many number of independent equations. So I will just come to some example.
Sir?
Yeah.
Sir, what do we mean by meshes here? Is it loops?
Yeah, I will just show about these meshes, by an exact example. We within these windows, we will consider the meshes.
Sir, please hold the slide for 10 seconds.
Okay, sir.
10 seconds, okay.
Sir, in this case, nodal analysis can't be used, right? Nodal analysis.
So all analysis are different techniques,
No, sir. In this type of circuit diagrams, we can't use that. Where we will take the reference node.
Okay, that is a good question. So reference node, somewhere you have to decide. Okay, it may be the this end of the battery. Okay, so there is a power source. So the other end can be the reference node.
But it is not connected to all the other nodes.
Which one?
That reference node.
No, reference node need not be connected to all reference. It is some reference only. It is connected to this. So this is the node that is common to one circuit element and the voltage source.
Okay.
Sir. Sir, I don't know, this might sound like a stupid question, but why can't we use mesh analysis for non-planar circuits?
So those will actually need advanced other algebraic techniques. Okay, so those techniques you will study in your if you are a electrical engineering student, you will node a student there is courses on signals and networks, there you will study.
But sir, we can always define a shortest loop, right? So we can define a mesh even in non-planar.
You can try out, because it will actually it will involve more number of variables and less number of equations.
Okay, understood.
Okay, so all those problems will start.
Define a mesh.
Yeah.
Please define mesh.
Yeah, I will come with actual example. Where you will have to move around meshes only. Okay. To solve this type of problems, you will have to move around meshes only. Okay, so I will just come with actual example. So suppose I have taken a simple voltage, simple circuit. Okay, 3 resistances, connected in the form of a, English alphabet T. It is actually called T circuit. Okay, since it is connected in the form of a T and 2 voltage sources. Okay, and the 2 voltage sources, you just see that this is a 42 volts and this is a 10 volts, but it is, see, the polarity is different. Okay, now if we suppose this current through this branch is I1, ultimately, once you are given a circuit, the job is to solve for the currents or whatever electrical quantity has been asked. So suppose this current through this is I1 and current through this is I2. So if you apply, so what is happening at this node, at the central node? This is I1 is the incoming current, I2 is the outgoing current. So what is the current?
I1 minus
I1 minus
I1
I1
minus I2.
I1 minus I2 is the current through the 3 ohm resistance. Okay, so now you are given voltage sources, and ultimately the objective is to find out I1 and I2. Okay, so since it is the voltage sources, we will go for the mesh analysis technique. And suppose we consider this as the first mesh. Somebody was asking the mesh.
So it can be also done by Kirchhoff's loop law.
Yeah, it can be done by many methods. A problem once given, it may also happen. You are given a problem and no method is stated. By any method you solve it and give the values. Okay.
Okay.
So I have shown basically a mesh. Okay, first mesh, and there can be a second mesh. Okay, because you see here in this circuit, basically there are 2 windows. This is the one window comprising this 42 volts battery, the 6 ohm, 3 ohm, and this is one mesh. And this 3 ohm, 4 ohm, and this 10 volt battery is another mesh. Now this 3 ohm is basically common to both. Now, how to write down those mesh equations? Okay, so mesh equations basically means, writing down the KVL as we go around the mesh. Okay, writing down the KVL, that means we start from one reference point in that mesh, go around the elements, whether it is a battery or a resistance, and then ultimately we have to finish it here and write down the KVL equation. So if we consider in the the left mesh as mesh 1, we already told, and if we write down the KVL equation, so what is happening? Suppose we consider this base as the starting point. So from here to here, what is happening in the battery? That is what is happening to the
Increase
voltage.
in voltage.
Voltage rise.
Increasing.
Voltage rise. Okay.
voltage rise.
Plus
So suppose we consider voltage rise as positive, so that is voltage is rising. Okay. Now this current I1 is flowing through 6 ohm. So what is happening here?
Voltage drop.
Voltage drop, because in the 6 ohm the left hand side is at a higher volt potential, the right hand side at lower potential. So and the current flows in this direction from the higher potential to the lower potential. So there is a voltage drop. So voltage rise we have considered as positive 42. Now this voltage drop is what?
Negative.
Negative.
Minus 6I1.
Minus 6I. Okay. Now then we proceed along with that mesh. So what is happening in the 3 ohm? The current is
minus
the current
3 I1 minus I2. I1 minus.
Yeah, the current in 3 ohm is basically I1 minus I. So it is minus 3.
I1 minus I2.
I1 minus I2. Okay. So we have gone around the mesh. So we have started from here. We cross the 42 volts, then the 6 ohm, the 3 ohm, and then there is nothing else. We have actually reached again the base of the 42 volts. So all the elements are covered in mesh 1. So this is basically equal to 0. So considering the mesh 1 and applying the KVL, so this is how we apply. We consider the voltage rise as positive and voltage drop as negative. We have written down the mesh equation corresponding to mesh 1. Similarly, if we consider the right hand mesh, because ultimately there are 2 variables, I1 and I2, and you need 2 equations to solve it. So basically you have to you make use of the other mesh. Okay, so if you make use of the other mesh, what will happen? Suppose this 4 ohm. In this 4 ohm, what is happening? If you go in this direction of the mesh,
Voltage drop.
-4i.
voltage drop.
decreases.
Okay, so it is -4i2.
-4.
4 ohm and I2, and the current is flowing. That is, current is going from higher potential to lower potential, voltage drop. What is happening in the 10-volt battery in the
10
direction of
volt
the
voltage rise.
voltage rise?
Voltage increases.
So it is the plus 10 volts. Okay.
Yes, sir.
Now what is happening in the 3 ohm?
Voltage rise.
-i.
Voltage
Rise.
Rise, sir.
In our direction, it is rise.
in our direction it is rise. It is correct. You know who told this? In our direction.
Me, Soham.
Soham. Yes, because what has been done is we have chosen a direction, and in that we have to consider that direction only. If you choose the other direction, you have to strictly follow it. We have chosen a direction, and you see in this direction what is happening is in this 3 ohm, we are going from, because the current is from the top to bottom, we are going from the lower potential to higher potential. So this is basically voltage rise. So what will be happening in the equation?
+3i1 -i2.
Plus 3i1 minus I2.
Plus 3i minus I2.
I1 minus I2. Okay, plus
Yes,
3i1 minus I2. That should not be. So the point is, first you indicate the current directions, write down the currents. Okay, and then wherever you are in node required KCL, find out the currents on the other branches. It is better to assume as less currents as possible. Because you can assume I1, I2, and then I3, but anyway I3 can be generated from I1 and I2 also. So
Yes.
and so we have started from here, went through the 4 ohm, then through the 10-volt battery, and then through the 3 ohm, and then ultimately we have reached here. So this becomes equal to 0. Okay, so now you solve it by using two variables. I am deliberately choosing because to explain the class, which we can do it handily, but it can be any number of variables. So for 2 variables, you should be able to do even without algebra, even without matrix or some other technique from your school level, from your 7th class, 8th class, you know how to solve this type of equation.
I2
Yeah. How much is it?
I1 6, I2 4.
So I1 equal to 6, I2 is equal
Sir,
to 4.
I1, I2 4.
Yeah, so you can check with these values whether these equations are getting satisfied.
Yes, sir. They are satisfied.
So 6 and 4.
So 6 and 4. So deliberately I'm
Yes,
choosing,
sir, 6 and 4.
I have chosen simple circuit, a T circuit with just 2 windows, 2 meshes, such that the concept of mesh can be explained. But gradually, if you take the books, there are a lot of numericals. There are books on electrical engineering, the numericals problems. Okay, so there you can have more complicated circuit, but the main trick is to write down first assume the variables, and then with as minimum variables, obviously, and then write down as many mesh equations, because you have to identify 2 variables means 2 meshes. You have to identify, apply the mesh KVL correctly, apply the KVL correctly in the meshes,
Sir?
and then yes.
Sir, can we not apply on bigger loop, both containing that loop?
Yes, we will do. You can also do that. Those
But
two works
sir,
we can
then
do.
what is the meaning of mesh here? Only we are using KVL here.
Yes. The bigger loop means which one? You can choose another loop. You can.
So he is
you can
talking
choose
about the
another-
entire outer loop.
Yes,
Okay,
sir.
you can also do that. You basically need 2 equations. You basically need 2 equations.
Sir,
Okay,
but the entire outer loop is not a mesh, na?
Huh?
Yes.
Sir,
Mesh
do
is
we
the
call the entire
shortest
outer
loop.
loop a mesh as well?
So that will also become. You try that. You solve it, whether basically it is the same circuit, whether you get the same answer or not.
Yes, sir, we
Sir,
will
what is
get
the
the equation from there also. I was asking that do we call the outer circuit a mesh as well?
Outer circuit?
Mesh.
Sorry?
Sir, he is actually
Can we
asking
call
that the
outer
bigger
circuit
window
as a
is
mesh?
the bigger window. Can we say that the bigger window is a mesh?
Bigger window is also another mesh. We'll do a more complicated example. The next example is a little bit complicated. Okay, you try to solve it.
Sir, I have a question regarding considering the outer loop.
Okay.
So, if we consider the outer loop,
Hmm.
I am getting a different equations, and along with that, the second equation that I'm getting, if I apply, will I not get different answer?
No, it's basically the sum of both the equations.
Oh, okay.
Yes, exactly.
Okay.
So can you
do
show
this.
the question once?
Yes. I have to show. You have to solve it. So this is the question, and what we will do is first we will indicate the direction of the currents. Hello, can you hear me?
Yes, sir.
Yes, sir.
Yes,
sir.
Yes, sir.
Yes, sir. Yes, sir.
Yes,
So I am giving the direction of the currents. Okay, and so if the current, this one is I1 and I2, so obviously this current becomes I1 minus I2. Yes.
Sir, this 6-volt battery, which terminal is positive, above one or below one?
Above one, you cannot see. Yeah.
No, sir, it is not visible.
Maybe 6 volt battery, that above terminal is positive, 7-volt battery also above terminal is positive.
Okay, sir.
Okay, so since as soon as it is I1 and I2, so obviously this at this node the current becomes I1 minus I2. And similarly, if this through this 1 ohm resistance I consider the current to be I3, then at this node what happens? The I2 is coming and I3 is going in this. So to the intermediate 3 ohm resistance, the current is
I2 minus I3.
I2 minus
I2
I3.
minus I3.
Okay, so this is I2 minus I3 through 3 ohm. So at this node, what is happening? From one side, the current is I1 minus I2. From the other end, the current is
I1 minus I3.
I1 minus I3.
yeah.
I1 minus I3.
Yeah. So if you apply KCL here, you get I1 minus I3. So now we have got the currents in all the branches. But obviously we have tried to assume the minimum number of currents. You cannot choose I1, I2, I3, I4, I5, I6. And obviously they are again related, but we'll have to go for the minimum number of currents, assume, and then write down the mesh equations. So write down the mesh equations here and solve it. Suppose I choose a mesh like this. The mesh will basically indicate, if you just change the direction, you will get the same equation but with a different sign. Suppose I choose a mesh like this. Some of you unmute your background, otherwise I will mute you. So these are the three meshes I have assumed. You can choose the other way also. If other way also you should get the same equation, but with all the signs will be different. So write down the correct mesh equations and then solve it. And
So
give
can
me
we take the
value.
outer entire loop as a mesh?
Right, you can do all sorts of things, but do something that makes your life also easier. Okay, the things that you can very clearly visualize. Because at the end of the day, you should not yourself get confused about the equations and signs and all.
Okay, sir.
So could anyone solve this? So it is very important to
I1 is
correct.
coming
Sir,
minus
2.99, 1.99, 2.99.
I1 is 34 by 13.
No, it will not be that search is wrong.
2.99, 1.99, and 2.99.
Sir, I1 is 3 ampere, I2 is 2
Sir,
ampere.
I3 3 ampere.
Okay,
I3
then
3 ampere.
I3 3 ampere.
2 I2 2 ampere.
yeah. So I don't know whether this 2.99 or that type of value will come. You need to check. Suppose you consider the left mesh.
Sir, whole numbers are coming.
Whole number should come. So the left
No,
mesh.
sir, it's exact.
Exact. So somebody was telling 2.99.
Getting a different sign.
No,
The
sir,
I3 is 3.
I3 3, I2.
Yeah, you just see my solution.
Getting the
if you
same answer with a different sign.
So 3, 2, 3. I1 3, I2 2, I3 3.
Sign,
Yes,
if you
sir,
have a
3,
sign
2.
change, there is no given my directions, all should come positive.
Sir, 3 to
Yeah.
3 is the answer.
So considering the left hand mesh, your equation will be, say, from the 7-volt battery, there is a voltage rise. And then again, to the 1 ohm resistance, there is a voltage
Minus
drop.
I1 minus I2.
So minus
Minus
I1, minus 1, I1 minus I2.
Yes.
Then through the 6-volt battery, there is a potential
Minus
drop.
6.
Minus 6. And then
Yeah.
potential
Minus
drop.
bracket I1 minus I3.
Minus 2 into.
Minus 2 into
Minus
Okay.
2 into I1 minus I3. I1 minus I3.
I3.
Perfect.
So consider the next mesh.
Minus
So in
2
that,
I2.
so it is 1
Minus
I1.
2 I2.
If you consider this 1 ohm first.
I2. Okay,
So
1
what you
into
are,
I1
1
minus
ohm
you are
first,
going
then
from lower
1
potential
into
higher
I1
I1
minus
minus
potential.
I2. 1 into I1 minus I2.
Then minus 2 I2.
Minus
then
2
minus
I2.
2
Yes,
I2.
sir.
Minus 3 into I2
Minus 3
Then
into
minus
2 I2 minus I3.
I2 minus I2.
Okay, and equal to 0. Similarly, considering the mesh, obviously, there is another problem. This is mesh 3.
Starting from?
Starting from
Just let me show.
3, sir.
So you got this?
Yes,
Considering
sir.
the
Yeah,
third
sir.
mesh,
First to
So 2 into I1 minus I3.
then
Minus
plus
I3.
6. Plus 6.
Plus
The
3
2
into
into
I2
I1,
minus
I3 plus 6. Again,
Minus
voltage
I3.
rise.
Yes.
And then minus
Minus I3.
Minus I3.
1 into
Sir,
I3.
you
Okay.
Yes.
1 into I3.
Yes, sir.
So once you solve this, okay, so you have 3 variables, 3 unknowns. 3 unknowns and 3 equations. Okay, so if you solve this, you get I1 equal to 3, I2 equal to 2, and I3 equal to.
Sir, 1 minus I3 will be there. Yeah, done. Okay.
Okay. So this is how you basically you have to solve the circuit. You can solve the circuit given the mesh analysis method. Okay, so what we have basically learned is we have basically learned to solve the circuits, because any electrical circuit is basically will need a source. Without any source, the meaning of the circuit it is meaningless. It is a battery in case of the power of the country. It is basically a generator, and so on. So you basically need a source, and then ultimately you need circuit elements through which the current will pass, the power is transported. Okay. So basically need to solve the circuit, so different values of the current. So we just explained using the two techniques, the nodal analysis and then the mesh analysis. So I will give the names of the books at the end of today's class. In the books you will actually get lot of numericals So all these techniques, once first you follow my notes, you follow the books, and then I would advise you to, independently solve the entire exercise. There will be solved problems, there will be unsolved problems. I will give you some good books, and you need to solve them independently, all the exercise, and check for the answer.
Sir, will you give any assignments for us?
Yes, they will gradually come. They will gradually be done, because they will be done throughout the sections. All through the sections it will be done. Okay, and basically on next Tuesday there will be the first tutorial. Okay, all the section 1 students will be with me, and section 2 students will be with Professor Huck. So the tutorial sheet will also be given, and in fact in our website you can get the old tutorial sheet, but the tutorial sheets have been slightly modified. Okay, so that tutorial sheets will also be given to you. So the tutorial sheets will be once, because many of these topics are getting done, so you can start doing the numericals from those sheets, or also from the books. I will refer the books at the end today. So the next topic that we will do basically is circuit theorems. Okay, so electrical engineering is all about theorems, because once the circuits are there are a lot of theorems have been proposed, and we can make good use of these theorems for solving circuits. Okay, so for circuit theorems, first we will define some terms, because there are many types of circuits are possible, but we will do the circuit theorems are relevant to particular types of elements. Okay, so we will first define them, and then we will go ahead with the circuit theorems. So the first definition is basically there is something called a linear element. Okay, so linear element is basically a passive element that has linear voltage current relationship. Okay, so the relationship between the voltage and current of that element is basically linear. So multiplication of the current through that element by a constant results in a multiplication of the voltage across the same element.
Sir, what do we mean by passive element?
Passive element means that something which is like inert. It does not generate anything on its own. So just like passive, there is an opposite thing active. Okay.
So although the capacitor or inductor would be active elements.
No. That will come gradually. Right now we are restricting ourselves to resistance.
Okay,
sir. Once we will define capacitor,
then linear elements. So then linear elements are nothing but elements which obey Ohm's law, right?
Right now we will stick to that. That is having a linear voltage current relationship. Anything, it may be something else also.
Sir, sorry to disturb, but sir, I was disconnected for the last few minutes. Sir, the name of the website which you are telling?
I did not tell any website.
Sir, that previous year's tutorial sheets will be found.
Okay. So that I will give. Okay, that maybe at the end I will write down somewhere.
Okay, sir.
Okay. Now there is another definition which is called bilateral. So bilateral means a circuit element that has similar behavior from both ends. I have just kept capacitor inductor here, but we will restrict ourselves to resistance here, because capacitor inductor will define later. A circuit element that behaves similar in both ends is basically a bilateral element. Okay, so suppose you have a piece of resistance, a lot of colorful resistance pictures I showed in the last class. Okay, so if you connect at either of the end the voltage source, it will work. It will carry the same amount of current. So that is how the resistor works. You must have done some experiments in your school level also using resistances. So that is basically bilateral, because it works in both ways. Okay. So once it is bilateral, the other one is unilateral. Unilateral means it has different behavior when both the terminals are used.
Diode.
So can you give an example?
Battery.
Diode.
So a circuit element having different behavior from both ends, like you all know diode. Diode, then other elements. Yes, the thyristors and so on. Because the diode forward bias is one type of characteristics, reverse bias is another type of characteristic. Okay, so in this course we are not concerned about all those unilateral elements. We will be restricting ourselves to bilateral elements.
Sir, how will we classify a transistor here?
You tell.
Because it has 3 different modes in 3 terminals.
3 terminals, but you know, okay, trilateral. But suppose you keep the base in one is base collector, and the other is the drain. Emitter base collector. You know, so are they? Can they work anyway?
No, sir. No, sir.
So you have to answer that. You know.
No,
so,
sir. 3 are different.
So diode is one. The thyristor. Some of you, those who will study electrical engineering, will study them in your 3rd year. So they work in different ways. Thyristor is it also has a 3rd terminal which is used to make it conducting. So through the 3rd terminal it has to be fired, so that it conducts in that direction.
Okay.
So these are the things that we have defined: linear, bilateral. So we will be concerned with the linear and bilateral only. Okay, so let us start the first.
Sir,
excuse me, sir. I have a doubt in
the
the
voltage sources like a battery or a cell won't be a unilateral element.
Which one?
Sir, a battery or a cell, won't it be a unilateral element?
No, they are basically the sources. They are not elements. We are talking of circuit elements. They are basically sources. They are part of a. Okay, they become part of the circuit, but they are basically the generators. We cannot consider a circuit without battery. Just you make a circuit, but there is no battery, it is meaningless. It does not serve any purpose. Yeah.
So, but a charged capacitor can also behave in the same way.
Sir.
Yes.
Hello, sir.
So
what is the difference
function
between
V of t is
KVL
equal to Ri of t? So the function V of t is equal to Ri of t.
Vt equal to very good question. Somebody asked Vt. Okay, I should not have kept the t. Okay, you all know V equal to IR. Suppose that voltage is also varying with time and current is also a function of time. We will gradually come to that. We have not come to that. Current function of time, and so we will come to that because that is AC. Okay, current function of time and V is also function of time.
Sir, I have a doubt in the definition of linear element. Sir, if we multiply current by K, then it is written that voltage will also be multiplied by K. But this means that voltage and current are equal. How is that possible? The multiplication constant for voltage should be different.
Yeah, but okay, there may be some mistake here, but it is just to indicate the proportionality. Whether you multiply I with R or multiply V with 1 by R, is basically that type of thing I am talking about.
No, so they are actually proportional. So
yes, sir. The definition is correct.
If one increases by K amount, then the other should also increase by K amount if the resistor is constant.
Yes. So the first theorem that we will do is called superposition theorem. As you know, what is the meaning of superposition?
Sir, algebraic addition of more than one.
So superposition, like you must have done in your,
like addition of vectors.
Yeah, in your vectors, you have basically.
Sir.
You have done in your vectors. If you have two force vectors, ultimately the effect will be the effect of both. Okay, so in a circuit there can be not just one voltage source or one power source. There can be multiple power sources. Okay, and like we have given examples of simple examples with 2 voltage sources, 3 voltage sources. Okay, so current sources and all. So that is just for the purpose of developing the concept and solving problems. But if you consider a city, whether you are in Delhi, Bombay, Calcutta, or somewhere, the cities are supplied by different sources. You cannot have just one source supplying to a city, and then that source goes, means the whole city becomes dark. Okay, so the cities are actually supplied from multiple sources. Now, ultimately, using both the sources, you need to find out what are the currents inside the there are all our customers. There are a lot of housing colonies. There are hospitals. There is IIT Delhi. There is maybe airports, big malls, metro rail. Everybody is the consumer. Huh? How many of you are from Delhi here? So the city of Delhi. Huh?
I'm from
Sir,
Noida.
I'm from Delhi.
Okay. Noida. Okay. Anyway, so many people are there. So the city is supplied by different sources, and if some source has some problem, so the other source can compensate for that. Okay. So Delhi may be fed by thermal power plants. It can be fed by hydel power plant. It can be fed by the solar power plant from Jaisalmer and so on. So once the solar power goes, the other power sources should be able to provide the power. So the purpose of this superposition theorem is, if you have multiple sources, you can solve the circuit by considering the sources individually first and then superimposing their effect. Okay. So like if you consider the, suppose IIT Kharagpur is a huge campus. You are yet to come. You will come. More than 15,000 students are staying here, of all categories, BTech, MTech, PhD, and research students, project staff, and all. Then there are about 700 faculty members. There are about close to 1,200 staff, and many people are staying. It is just a mini township. So even IIT Kharagpur, you cannot rely on only one power source. It is actually fed by two sources. Okay, so I gave the names of some of the power companies. Like it is fed by that DVC, Damodar Valley Corporation, that company I named. It is from one side, IIT Kharagpur is supplied by DVC grid, and the other side it is also supplied by the West Bengal State Electricity Board. So from both sides, the supply comes to IIT Kharagpur. And if suppose there is some problem with DVC, even IIT Kharagpur will get power from the other end. So the purpose of superposition theorem is, if you have multiple sources, how to solve the circuit. You can solve the circuit even by considering each of the source individually and then superimposing their effect. So this is the statement of superposition theorem, that in a linear bilateral resistive network, the voltage across, so when you consider the voltage, suppose you find out what is the voltage across some element. The voltage across a resistor or the current in a source, that is how I have written, voltage across or current in a resistor or a source may be calculated by adding algebraically all the independent voltages and currents caused by separate independent sources acting alone. So you have to consider one source at a time. Okay, if you have n sources, you have to basically solve the circuit n times. So when you consider one source, you have to keep all the other sources inactivated. Okay, you have to keep all the other sources inactivated. So by inactivated, what does it mean? If there is a voltage source, to inactivate means it has to be short circuited. Okay, so you remove the voltage source and connect by a wire.
Will
so
not
that
consider
is
the current from those sources.
Yeah, so voltage sources will be sorted and current sources will be basically open circuited. So that is basically the theorem of that, the superposition theorem. That if there is a linear bilateral resistive network, the voltage across or the current in a resistor or a source may be calculated by adding algebraically all the independent voltages or currents caused by separate independent sources acting alone, with all other independent sources inactivated. So by inactivated, what we mean is voltage sources short circuited and the current sources open circuit. So this thing you have to meticulously do when we do, when we solve some circuit using superposition theorem. We'll do many circuits. We'll do some examples in the class, when whatever books I will refer, we'll have a lot of examples. And when the same examples you can do by any other method and verify with the results of superposition theorem.
Sir, this theorem is also valid if the circuit contains capacitor and inductor and all those. Or
so that we will come later. We are not focusing on that now. Only for the resistive network. Let us understand the concept and do the numericals. Okay, we'll gradually come to those terms, those elements. We are right now talking of element, and we are only talking of resistive element.
Sir, but in definition it is written as bilateral.
No.
Then it cannot be capacitor and inductor.
We will come to that. I'm telling you, no, we will come to that. Right now, we will be solving only with
Those
the
are also
resistive.
bilateral, no?
Yes, but I've
Those are
written
also
linear bilateral resistive network. Okay, all my examples right now will be only on the resistive network. So you are given a simple circuit to explain. So it is having two sources. I have given one as a current source and the other as a voltage source. And suppose the problem is, what is the current through this 9 ohm resistance? There are two sources connected. So find the current through the 9 ohm resistance by applying superposition theorem. So what you have to do is, you see that language that it can be calculated algebraically by considering the sources independently. Okay, so independent sources acting alone. So basically you have to consider once the voltage source acting alone, and once you consider the voltage source, you have to basically inactivate the current source. Inactivating current source means open circuited. And once you consider the current source, the voltage source has to be open circuited. So it basically means shorting it. Voltage source is shorted. So if we consider only the voltage source, we basically have a circuit like this. So you see the same circuit, I am only considering the voltage source, means I have to deactivate the current sources. And deactivating current source means open circuiting. Open circuit means I have cut it from here and I have removed it, and so it becomes like this. Okay. Now if you consider, so in this case, if you consider only the current source, what will happen? The current source will be there, this will be there, and this 3 voltage will be basically shorted. So your circuit is like this. So I have kept only the current source and I have deactivated the voltage source. Is it clear?
Yes, sir.
Because there are only two circuits.
Yes,
I have given you a very
Yes, sir.
simple circuit, one voltage source, one current source, just to explain. Yes?
But in second case, why you are connected by connecting wire, but in first you are not connected that. You are removed total.
Okay, very good question. In the first case, what I am doing, I am only considering a voltage source and I am inactivating the current source. Okay, so inactivating the current source, you see, current sources should be open circuited. Open circuited means it has to be left open. I just remove it. Okay, and in the second case, I am only considering the current source, so the voltage source should be deactivated. So inactivating a voltage source basically means short circuiting. I am just removing the voltage source. I have removed this 3 volt and directly connecting it. So that is called short circuited. Does it answer your question? Somebody asked.
Yes. Yes, sir. Yes, sir.
Second loop has some resistance. We can open circuit it.
Which one?
Along with the 2 ampere current source, if any resistance is there.
Okay, those are there, but here we are considering an ideal current source as if those connecting wires are having nothing. Only, we are not considering any, internal resistance and all.
No, sir. Along with 2 ampere, if some resistance is also there, some 3 ohm, 4 ohm, then we can open circuit it completely.
For which case?
In the same case, along with the 2 ampere current source, if some resistance are also there in the loop.
Okay, so for which case you are talking? First case or second case? Considering the voltage source or considering current source?
Sir, if in the question, along with the 2 ampere current source, in the second loop, containing 2 ampere 9 ohm, some additional resistance also there.
Yeah, let there be resistance. What is the problem?
Then we can open circuit it completely.
No, we will only open circuit the source.
Okay.
We will only open if there is some resistance. Okay, there maybe in some other numerical we will get resistances also, but we are only concerned about removing the source or inactivating the source.
Okay, sir.
Incidentally, okay, some resistance was not, but anyway, I think we will get problems of the numericals where those things will be there. Here, anyway, the problem was like this. So, in these conditions, so see, our main problem was what is the current through the 9 ohm resistance? This Ix. Okay, so now this Ix will be contributed by both the voltage source as well as the current source. The Ix will be, because since there are two sources, both of them will be contributing to the Ix. Now the superposition theorem states that we can find out this value by considering each of the sources individually. So considering the voltage source, what is the value of the current? Suppose we tell it Ix1, the value of the current due to the voltage source. Huh?
1 by 5 amperes.
4 by 5 with 9 ohms.
3 by 15. Okay. It is 3 by 15. Simple circuit. 3 by 6 plus. Will these terminals have any effect?
No, sir.
No,
These
sir.
are just open wires. Okay. You only have current when the circuit is closed. Okay. So only the circuit. So Ix1 will be 3 by
15.
9 plus 6. That is 15. So Ix1 is 3 by 15 equal to 0.2 ampere. Now you have to find out Ix2. Ix2
1.2.
2 into 6 by 15. Current division formula.
0.15.
So this current is getting divided. These 2 amperes is getting divided between 9 and 6. The current division formula is the total current.
1.2.
So opposite resistance by the sum. So it is 6 by 15 into 2.
0.8.
0.8. Okay.
0.8.
So I have found out the individual currents when the sources are connected individually and the other source as inactivated. Okay, so but the superposition theorem states that if there are multiple sources, okay, so you can apply superposition to find out the unknown by considering one source at a time. So we have found out by using once the voltage source, once the current source. So the total current through the 9 ohm resistance, which is Ix, is basically equal to Ix1 plus Ix2 equal to 1 ampere.
1 ampere.
Okay. Clear? Superposition theorem?
Yes, sir.
Yes, sir.
Yes, sir.
Yes,
Very
sir.
nice
Yes, sir.
theorem. Very nice theorem. I am trying to explain through a very simple example, but in the books you will get lot of challenging examples that you should try and solve and do it correctly. Okay, I will give the references at the end. So that is superposition theorem. Very nice theorem, very elegant theorem which you can apply. And even you can find out, verify your results with, mesh analysis, node analysis. Same circuit you do by different techniques and find out, verify the results. Okay. So let us do one example. Suppose this is the example. I am getting a little bit complicated. And the question is to find out what is the current through the 15 ohm resistance. I am assuming that Ix in that direction. In that direction, what is the Ix? Okay. So what will you do? You will consider how many sources are there?
2 sources.
2 sources.
2 sources. So the left side is the current source, right side is the voltage source. Suppose you consider only the current source. If you consider only the current source, what will be your circuit? You consider this part will be there, the voltage source will be shorted.
Short circuited.
Short circuit. So a short circuit, how much resistance is it? So what will happen if there is a short circuit here? Short circuit.
5
5?
5 from resistance.
That is shorted. Shorted across 5 means what?
The 5
Short-
resistance we can
No
run
voltage
fast.
across in our circuit.
Zero, sir.
Means
Zero.
no current will pass through
Zero
it.
there.
Short circuit means how much resistance value?
0, 0.
Zero.
Zero, zero.
So
we
zero
can remove the
parallel.
5 ohm.
Zero.
So zero parallel equivalent with 5 will give you how much?
Sir, what is the direction of the battery? Means which side is positive? It's not visible here.
The top side is positive.
Thank you, sir.
So this
Sir,
is basically
is
the
there any
condition.
proof for the super?
Yeah, those proofs are there. You can get it in the books. The proofs on these theorems. We will basically state the theorems and try to use it. So this is short circuit. I have shown. So short circuit means how much value?
6.
Huh?
0, 0.
0. So the equivalent of parallel equivalent of 0 and 5 is how much?
0.
0. So what will be similarly considering only the voltage source? So right side is the voltage source. What will you do with the current source?
So current division parallel.
Open circuit.
No, what open circuit. So this is your
Open
circuit.
circuit.
Okay. Yeah, they are open circuit.
Yeah, open circuit.
Open circuit. Okay, so this is the circuit.
Yes.
So right now, if you consider, so this is IX1 and this is the IX2. Okay, so the current IX1 is this. Similarly, the current IX2 is basically in this direction because this cell battery pushes the current in that direction. So you see here what is happening is through the 15 ohm battery ohm resistance. For the two sources, the current directions are different. So what will be the algebraic sum?
0.66
Huh?
0.66 amperes.
So it will be algebraic sum means Ix will be equal to
0.66 ampere.
0.66 ampere.
so it is equal to Ix minus Ix1 minus Ix2
Yes, sir.
and it is equal to 0.66 ampere which can be written as 660 milliampere.
Yes, sir.
Okay.
Sir,
Sir,
how
can
did
I
we
use
get
this
Ix1?
theorem for finding the current in 3 ohm resistor? Can I use the superposition theorem for finding the current in 3 ohm resistor?
Yes. Try it.
Yes,
Try
okay.
it at your home as a homework, to find the current in the 3 ohm resistor.
Yes, sir.
Find the current in the 3 ohm resistor, find it.
Sir, can you explain once more?
Huh? Suppose in the 3
Sir,
ohm
can you
resistor,
explain?
which one?
IX1.
Huh? Ix1 you could not understand.
Yes, sir.
What is the equivalent of 5 ohm and this short circuit?
0.
0. So 0 is in series with
Okay, sir.
15. 0 is in series with 15. Okay?
Yes,
How
sir.
much? How much?
15.
15. So here the current division, the 2 ampere is getting divided. So current division means what? Opposite resistance by sum of the resistance. So opposite is how much? 7 plus 3, 10
Yes.
by sum.
Yes, sir.
25 into 2 equal to 0.8.
Yes, sir.
Sum is 30, right?
Sum is 30. Who got 30?
Plus 5 plus 10 plus 30.
Who told 30? What is your name?
Ram.
Huh?
Ram.
Ram. How are you getting 30?
Sir, 15 plus 5 plus 10.
5 कहाँ से मिला?
5
Huh?
is there, no.
And what is this red line?
Yeah, but the 5 is not attached to the red line.
What is the meaning of this red line?
Short circuit.
Short circuit means how much resistance?
0.
So 0 and 5 का parallel equivalent how much?
Oh, okay.
Huh?
Yeah, I got it.
Got it? So 30 कहाँ से मिला?
Okay, it's 25.
Okay, you have to be very careful. Short circuit I am deliberately drawing by different color to make it clear, and 0.5 parallel equivalent, it will ultimately 0, and so you have to be very clear. 30 किया तो राम गलत हो गया. Okay, you will not get credit. Okay.
Yes, okay, sir.
So you can have more examples. You can have more examples. How much time is left today? Okay, half an hour. So that is clear, the superposition theorem?
Yes, sir.
Yes, sir.
So you must understand the significance of short circuit, which is zero resistance, and also open circuit means it is just hanging in the air. So then there will be no circuit, no current through it, because it is it needs the closed path. But you can measure some voltage here. Okay, in the open circuit, if you have a meter, you can measure the voltage. But we are not concerned about voltage. We are concerned about current, which needs a closed path. Okay. So the next theorem is basically called Thevenin's theorem. Thevenin's theorem.
Sir?
Yeah.
Sir, will you give some practice sheet for this question rather than giving assignment?
If you there are, but I can give you the names of 10 reference books. That will be a sufficient practice sheet. Okay.
But sir, in books we get confused which question should we solve or not.
Where? You have the tutorial. Books, there are a lot of problems. Whatever type I am doing, there is similar type and other questions are there. So
okay,
you will anyway get a tutorial sheet. You know, there are a lot of other books on numericals. So the next theorem that we are going to do is called Thevenin's theorem.
Excuse me, sir.
No.
Sir, do we have to follow books for theory or mainly for practice?
For both, actually.
Okay.
Okay, so Thevenin's theorem means is a theorem which states that if you are given an arbitrary two-terminal network, two-terminal means there is a network from which two ends are coming out. Okay, consisting of resistance and independent sources. So the whole network consisting of resistance and independent sources. Then there exists an equivalent two-terminal network. That whole network can be replaced by an equivalent network consisting of a resistance RTH, which is called the Thevenin resistance in series with an independent voltage source VTH. The voltage VTH, called the open circuit voltage, is what that appears across two terminals when no other network is attached. RTH, called the Thevenin equivalent resistance, is the equivalent resistance of the network when all other independent sources are deactivated. Again, this concept of deactivation will come. So across the two terminals, so I'll just show a circuit. So this is suppose there is a network. Okay, so that you can see the network. So I've kept within that complicated. Hello, can you hear?
Yes, sir. Yes, sir. We can see.
Yeah, so I have kept all that complicated network inside that shape, and suppose from that network two wires are coming out, and to that two wires is connected a load resistance. So that network basically consists of a complicated connection of resistances and independent sources. There could be voltage source, there could be current source, and so on, and with the complicated connection of resistances. Now that entire network, so what this Thevenin's theorem states is that the entire network can be replaced by this type of arrangement. So across these two terminals, these bubbles, so that is the RL, that is the load resistance. But the left hand side, the entire network can be replaced by a voltage source VT, which is called Thevenin voltage VTH, in series with the resistance which is called RTH or Thevenin resistance. Now, how to calculate these Thevenin voltage and Thevenin resistance? So this Thevenin voltage, called the open circuit voltage, is what that appears across these two terminals when no other network is attached. So across these two terminals, if you just remove this RL, and across these two terminals, if you measure using a voltmeter, whatever voltage you get is basically the VTH. That is, you remove RL and connect a voltmeter across these two points. The voltage that you get is basically called the Thevenin voltage. Okay. And what is RTH? RTH is basically the equivalent resistance of this network. That means looking from this side, looking from these two terminals, the equivalent resistance of this network when all the sources are deactivated. So this network is consisting of several independent sources. So you deactivate all the sources, and we know what is the meaning of deactivation. Okay, if it is a voltage source, deactivation means it has to be shorted, and current sources have to be open circuited. So after deactivating all the sources, what you are left with is the passive elements. Okay, and whatever resistance is there across these two terminals is basically the RTH. And once you have this, then it is very easy to calculate the current through RL, load resistance.
Sir, could you explain again?
I will explain.
So what is the advantage of this theorem?
Sir, I have to reconnect. My network problem was bad.
Sir, what is the advantage of this theorem?
The advantage is, suppose I have used the word load resistance. Load basically means some resistance. In actual practice in your home, it may be just a heater. Okay, or it may be just a bulb. Okay, so which is the resistance, and you want to find out what is the value of the current through it. What will be of interest is what is the value of current through it. So now this resistance is basically connected to this whole network. If you can replace this whole network by a simple voltage source and a series resistance, then you can very easy to find the current.
Okay, sir. Thank you.
Okay.
Sir?
Yeah.
After measuring the voltage by voltmeter, we can measure the current by ammeter and find the resistance by Ohm's law. That resistance won't be equal to the RTH.
What is the name?
Dhananjay Swami.
Dhananjay, yeah, you are very much correct. Basically, this Thevenin theorem you will also do in your lab. What I am teaching here is basically the theory, where this is required because you have to appear in exams and then score marks. But in the lab also you have to basically verify Thevenin's theorem. The theorem, it is a theorem, but it has to be verified in the lab, which you will actually do in the lab. Okay, and as Dhananjay is telling, there you have to do everything by experiment. Now, because of this pandemic, you are unable to do the actual lab. But if you are coming to the lab, you would have actually done it. You will be given a circuit and asked to find out the VTH and RTH, so which you have to do experimentally. But here, what we are teaching is to solve numericals in the class, in the exams, and so on. Now, as Dhananjay is telling is to determine it experimentally, which you have to actually do. Now, in this pandemic, you will not be able to do in the lab, but you will do what is something called virtual lab. Did you have any lab session so far with your lab teacher?
No, sir.
Okay, now you are doing mechanical lab. Okay.
Yes, sir.
So
Yes,
you
sir,
are just
mechanical
shown the
lab.
equipment and the different types of process and just
Yes, sir. The lathe machine.
No, okay, that is okay. You are doing engineering lab, the mechanical part.
Lathe machine.
Yeah, so but in the first week of from first week of electrical from the first week of January, you will be basically doing the electrical lab also. There you will do this experiment on verification of Thevenin's theorem. And this, in the pandemic situation, you will actually do it through a website. Okay, all the same experiments that are present in the lab is actually made through the software and available in the website free of cost. and then you can perform experiments there.
Yes,
Okay,
sir
and
told about it.
which sir? Sir told.
Yes, the sir who created the lab actually.
So that lab is actually called virtual lab, and that lab is actually developed under my guidance. Okay, that the electrical lab that he will all perform is actually developed under my guidance, and it has been done from 2010. Even before you were in school. From that time only we have been developing these labs. But in this pandemic, people have found the utility of this lab, because right now the same experiments can be done through the website. Okay, I can, if you want, I can share the website link also. Can you see what is written there?
Yes, sir.
Yeah, so that is the
Where,
lab.
sir?
Have you seen this? The B Labs website I have given at the bottom.
Yes, sir.
Huh?
So do we have to log
Oh,
in
sir.
with our
Yes, sir.
institute
Yes.
email?
There is no login required. It is a free of cost website. That is how the government has made it. The students don't have to log in. You can directly go and use it anyway. Your lab teacher will guide you. I am just telling you right now. Your lab teacher will guide you. There is no login required. There is no
Sir,
password.
so
There
if
is
we
no.
want, we can. Sir, if we want, we can go and do the experiments there on our own.
Yes, all the electrical experiments. The electrical experiments
Okay, sir. Thank you.
you will actually do from here. Okay, and you can even see that it has been developed under my guidance. You will see my name and all there once you visit this website. This electrical lab part, but for the other labs, other professors are also there. So that
Sir,
is the.
sir, can we do experiments after coming campus in second sem, Mister?
Yeah, that you can do. The labs are there present. You can just enter the labs. Obviously, taking the permission of the teacher and the lab attendant, you can visit those labs and do this. That is our ultimate objective. But we don't know when things will normalize. But this
Sir, will
website
the
is working.
separate sessions be arranged for the labs?
Sir, on going to this URL, it says 404 not found.
Is it?
Yes, sir.
Yes, sir.
Let me
Yes, sir. Yes, sir.
Huh?
Just remove ASNM from last.
No, you do. No, I'm just giving you the link. Maybe my link is wrong. Yeah, somebody told remove ASNM. That may also work. I actually have given the wrong link. I'm giving.
Sir?
Yeah.
Sir, can you give an example
Check this.
theorem?
Huh?
Can you give an example for the Thevenin's theorem? I'm not understanding.
Obviously, I will give you example. What is your name? Huh?
Abhiram.
Abhiram, there will be a lot of examples. Lot of numericals are going to come. I have
can
stopped
we
in this, but just check this whether this is working or not. Check this link. Okay. It is working from. I'm just checking. It is
Sir,
working.
excuse me, sir. In this Thevenin's theorem, we are replacing the entire network by a single battery and equivalent resistance. Is that what we are doing?
Yes.
Okay.
So we also used to do Thevenin during these capacitor problems and inductor problems.
In your school?
Yes, sir.
Yes, sir. During JEE.
So here we will
During
teach in a
JEE
different.
paper.
Yeah, we'll do it in a different way. We'll some other way will be there. Okay, so as Abhiram was telling, let us do some numerical on Thevenin's theorem. Okay, so I have given a simple circuit. Simple circuit, 3 resistances, 3, 7, 6 ohm connected with a 12 volts battery. And on the right side is the load resistance RL. Now what I want is to give me the Thevenin equivalent of this. So across these two loads, if we remove this, the Thevenin equivalent. So for Thevenin theorem, what we have to do? We have to find out the VThevenin. So these are the two terminals across which we want to get the VTH and RTH. So to compute VTH, as I told, to compute VTH, what we have to do? You remove these two terminals. You remove the load resistance across these two terminals, and you whatever voltage is there is basically the VTH. So what is your circuit? So basically this is the circuit. Abhiram, you are getting?
Sir, VTH is 8 and RTH is 9.
Yes, sir.
No,
Yes, sir.
So
VTH is
whatever
8,
it is.
RTH is 9.
Yeah. So once it is VTH, so across
Yes,
these
sir.
two terminals, whatever is the voltage. So across these two terminals, voltage means whatever is the voltage across 6 ohms. Because this is open circuit, there is no voltage drop here. Okay, so that is what is the voltage across 6 ohms. So this 12 volts is getting divided between 3 and 6. So it is basically 6 by 9 into 12.
12.
Similarly, to compute RT, whatever it is, some value will come. Yeah. So similarly, the other aspect of Thevenin theorem is to compute RTH. So to compute RTH, this is the circuit. That means across these two terminals, what is the equivalent resistance by deactivating all the sources? In this problem, there was just one source. I just kept it simple. I kept one source, but you have to deactivate. So deactivating voltage source means what? Deactivating voltage source.
Short circuit.
No, don't tell line. You have to tell the proper
Short
technical
circuit.
language.
Sorting it.
Short circuit.
9 ohms.
Short circuit means how much resistance?
9 ohms.
0.
9 ohm.
No, in the short circuit path, how much?
Zero resistance.
Zero.
So your circuit is like this. So right then, what is the equivalent here? So you see your VTH is 6 by 9 into 12, that is 8 volts. And similarly, RTH, it is 7 plus the parallel equivalent of 3 and 6.
9 ohm.
9 ohms. So right now, then you have a circuit.
Sir, how did VTH came? How did VTH came? I couldn't understand.
So you check the circuit on the left hand side. VTH means across the voltage across these two terminals. Now this 7 ohm is actually hanging in the air. So whatever voltage is here is also the same here. So what is the voltage across the 6 ohm resistance?
Sir,
Yeah.
RL and RTH is same.
Which one?
RL and RTH.
Is it same? Huh? The question is, I have told you to find out the VTH and RTH across these two terminals. So when we do across these two terminals, we actually remove the RL. And baki jitna reh gaya, whatever is remaining, what is the, you have to find the VTH and RTH there. Okay.
Okay, I got it.
So once you have this, what is the circuit? Once you have this, then you can replace VTH, RTH and RL. But okay, this circuit you also need the actual value of RL, which I have not given. Okay, if the actual value of RL is given, you can find out the current. We'll do some more example. Suppose I give you this. And I ask you to find out the current through the 6 ohm battery, 6 ohm resistance. You can hear?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yeah.
Yes, sir.
Yes, sir.
So 6 ohm is basically now the RL, through which you are being asked to find out the value of
Sir.
current. Yeah.
Sir, I have a doubt in previous slide.
Yeah.
Sir, in the to compute VTH, you said that the 7 ohm resistor is just hanging. But sir, if we see the original circuit, sir, it will be different there, no sir. It will be some voltage across 7 ohm resistor because RL is connected. And
So that is
for
the-
the sake of
so that is
for
in
the sake
origin.
of calculating, we disconnect it now. But actually, there will be some VTH there.
So that is the thing we are trying to find out. So to try to find out, you have to basically remove RL and then find out what is the voltage here.
Yes, sir, got it.
Okay.
Got it, sir.
Now, who was asking? You were asking, or somebody else was asking?
Sir, I was asking.
क्या नाम है?
Prathamesh.
Prathamesh. Okay. So now let us go to the another numerical where I have given RL. You know, the same type of circuit, T type of circuit is there, but I have given two voltage sources. And the question is to find out the current through the 6 ohm resistance. So basically, that is your RL.
Sir,
Okay,
I is 0.9729.
नहीं वो तो ठीक है. What is VTH RTH?
0.927.
VTH RTH, not by solving mesh and all.
VTH is 8 ohm and RTH is 20 by 9.
8 volt
Yeah,
and RTH is 20 by 9.
Yeah, but something will be there, but let us solve it. How to get it? So basically, you have two objectives to compute VTH. To compute VTH means, since I have asked to find the current through the 6 ohm, you basically remove the 6 ohm. And after you remove 6 ohm, what is the circuit? And similarly, to compute RTH, after removing 6 ohm and then de-energizing the two sources, what is the circuit? So to compute VTH, what we have, this is the circuit. The 6 ohm is removed. Rest of the circuit remains the same. Okay, I have removed the 6 ohm and the rest of the circuit remains the same. So what is the value of VTH? What is the value across A and B?
Sir, 8 volt. 8 volt. 8 volt.
Okay, so here you can, there are two sources, two resistances.
8 volt.
You can nicely find out find out the current and then what is the voltage drop and find out the voltage across A and B. Okay, similarly to compute RTH, it is basically the same circuit. Okay, the 6 ohm resistance removed, and then you have to de-energize the voltage sources. De-energizing means shorting. Okay, so this is the circuit. So if this is the circuit, what is the resistance across these two? The equivalent.
20 by 9.
20 by 9.
So it is the parallel equivalent of 4 and 5. So it is basically 20 by 9. So your VTH is, so in this circuit, what is the current? 9 by 9, that is the 1 ampere current is flowing. 12 volts minus 3 volts, 9 volts divided by the 9 ohms. So 1 ampere current. So VTH is 12 and whatever is the voltage drop across this 4 ohm. So 12 minus 9 by 9 into 4 equal to 8 volts. Everybody is getting this?
Yes, sir.
Yes,
Yes,
sir.
Yes, sir. Yes, sir.
And then RTH is this.
Yes, sir.
Okay. Any doubt about this RTH?
No, sir.
So you should be able to visualize what is happening. I have removed that load here because it was told to find out the current in the 6 ohm resistance. So the 6 ohm was basically the load. So we have removed it because everything we have to do after removing the load, because that is the question asked. And then we are finding out across those two terminals what is the VTH and what is the RTH. So RTH becomes across these two. So it is basically the parallel equivalent of 4 and 5. So it is 20 by 9. So now your circuit becomes, this is the thing. So that is the, you see that, remember the theorem. So that is the circuit now. Because we have found out VTH and RTH. So VTH equal to 8 volts, RTH equal to 20 by 9. And now you reconnect back the load, that is 6 ohm. So what we have done is, by removing the 6 ohm, the whole circuit has now been represented in the form of a voltage source, which is the Thevenin voltage in series with a resistance, that is the Thevenin resistance. And once this VTH and RTH is found out, you have to find out the current, because ultimately the question was what was the current in the 6 ohm resistor. So the now rest of the circuit is replaced by this, and now you can find the current. Very simple thing. V by R.
Sir,
So your current,
sir,
yeah.
why did we take resistors in parallel here?
Which one?
Sir, here we got 20 by 9, right? So, sir, if we remove the load, then it must be it must be in series, right?
Which one here I am taking it, I am telling to find the resistance between this point and this point, between A and B.
Oh, okay.
Between A and B, because the load is was across A and B only.
Okay, got it.
Okay. Clear? Thevenin resistance, Thevenin's theorem?
Yes.
Yes, sir.
Yes, sir.
So,
Yes, sir.
Yes, sir. Yes, sir.
So in the books you will find a lot of problems on these Thevenin theorems. A very nice theorem, a complicated circuit, just replacing. We will actually verify this theorem experimentally.
Sir, you said you would suggest some books for questions.
Yes, sir. Please suggest the books name.
Yes, sir. We need to practice. Can you please suggest?
Yes, sir.
Where is
Hello.
I think sir's connection.
Hello, sir.
Sir, you are not audible.
Maybe he has been disconnected.
Yes, I think so.
Hey,
sir is there in the
anyone
meeting.
understand this? Anyone
Sir is
understand
there in
this Thevenin's theorem?
Yes.
How did we take such RTH and plus this resistance?
Sir has left.
It is the equivalent resistance for the entire circuit.
Stay online till sir come. Okay.
Sir, my Datta, and I need to know some books. Oh, sir is not here.
Then
No,
type
sir is
down.
left.
I think he is here.
Did you
Not
know?
audible, sir.
Stay
Hello.
online till sir come. Okay.
Hello.
Yes, sir.
Did sir in the meeting?
Sir, no, sir is not yet in the meeting.
Due to network issues,
Hello.
sir might have
Time has
disconnected.
also
Yes,
ended
yes.
of
Please
our
wait.
lecture. Should we leave?
Okay. Those
What
who
are
are
we waiting for
lecturing,
then?
so they can leave. Those who are having lecture, they can leave.
I have a library meeting, so I can leave.
Time is also over, so I think we can leave.
Yeah,
Okay,
you
fine.
can leave.
Yes.
Can
Sir.
you
Just share the link for library meeting.
Yeah, can you share the link for the library meeting? Oh, me? No, it's actually registered. Those who have got the mail, they can only join.
Only 50 students are selected and send the link for library.
What's
Hello,
library meeting?
hello, I am
Which
back.
library meeting?
Hello, sir.
Yes, sir. Yes.
Sir is back.
Hello, sir. Yes,
Hello,
sir.
sir.
I got disconnected. I don't know. Can you see my screen?
Yes,
Yes,
sir.
sir.
Yes,
sir.
Yes,
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 Yes, sir.
Yes, sir.
Okay, so that was the Thevenin's theorem. The next theorem.
Control plus shift plus greater than is the shortcut key combination to decrease the font
Can you hear?
Yes, sir.
Yes, sir.
Yeah, so Norton's theorem is basically a,
Yes, sir.
a continuation of the Thevenin's theorem. That this here it basically states that I am not giving the language. That it is basically states that it can be connected, but replaced. That network can be replaced by a current source in parallel with a resistance. Okay, and that current source value is basically VTH by RTH, and that current.
Sir, we have another lecture. Can we leave?
Okay, we'll do this next day. Thank you.
So can you give the books related
Sir,
to
I
this?
will.
Can you give
Can I?
Yes, sir.
For the books, you have to listen to Norton's theorem. It was
Yes,
there
sir.
at the, it is typed at the end of Norton's theorem. Okay.
Sir, I have a doubt.
It is there in my slide only.
Hello.
Hello.
Sir, I have a doubt.
Yes.
We are here.
Sir, please provide the slide in which the books are mentioned.
अरे बाद में पूछ लेना.
Sir, can I leave? हाँ ये doubt अपना बाद में देख भाई. Sir, can I leave?
Doubt बाद.
Okay,
Doubt बाद
okay,
में
you can
पूछ
leave.
लेना.
Okay, all of you, some of you are asking about the books. You see these books.
Don't speak in Hindi, Praval.
Sir, I have a doubt, sir.
Okay, thank you, sir.
Note down these books names and they are full of problems.
Thank you, sir.
Thank you, sir. Thank you, sir.
Sir, which
Thank
one
you.
specifically to buy?
Thank you, sir.
All of them are good. You just because the more you practice, it is good for you.
Sir, is it enough to only make question of only any one book, or to all of 5 books?
It may not be enough. It may not be enough.
Hello.
So we have
Hello.
to do all the questions from
Sir,
all
are
these
these
5
books useful
Sir,
for
can
all
you
4
show the
years
names
or
again?
only for this
No,
semester?
no. Only for this subject.
Sir, can you show the names again?
Again?
Yes, sir, please can you show that slide again?
So which is better for theory?
All of them are good.
Okay, sir.
Okay,
Sir,
thank
do
you.
they contain practice problems as well? These books?
Lot of problems.
Okay.
Thank you, sir.